Before we go over the solution to this equilibrium problem, hit pause and give it a try yourself. When you're done, hit play. The first thing we have to do is we have to figure out how much of the initial reactants are inside of our beaker. 10 milliliters of A, which has a concentration of 0.5 moles of A per liter, means that we have a grand total of 5 millimoles of A, or 5 times 10 to the minus 3 moles of A in our solution. Applying the same technique to B, we get a beaker that has 5 millimoles of A and 10 millimoles of B and no C initially. Now we'll set up an ICE table in order to solve this problem. Remember, ICE refer to initial, change, and equilibrium. These are questions that we're going to ask. So the first square is what is the initial concentration of A? We have 5 millimoles of A in 100 milliliters, which means we have an initial concentration of 5/100ths molar. The initial concentration of B is 10 over 100 molar, and the initial concentration of C is 0. I like to add a column for Q, the reaction quotient, which in this case is going to be 0 initially. And since it's 0, it must be less than K, which means the change will involve forming products and consuming reactants. So minus XA minus X for B and plus X for C means that at equilibrium, we will have a concentration of A, which is 0.05 minus X, a concentration of B, 0.1 minus X, and a concentration of C, which is X. And at equilibrium, Q will be equal to K. The problem also then states that at equilibrium, the concentration of C is 0.025 molar, so we'll plug that in for X. Plugging these values into the expression for K, we get a value of K that's equal to 13.